Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa sallam. Ameen. Alhamdulillah rabbil alameen. We should be honest. Differentiation lecture 6. In this lecture, I will first discuss the solutions of some important examples, and then I will discuss the solutions of some important questions from past papers. Example number 1. Y is equal to tan inverse x. The differential of tan inverse is 1 upon this angle, must be here, and plus 1 with whole square here. And the differential of 5x must be here. This is the way to differentiate the tan inverse function. Well, this is the simplified form. Example number 2. We have f of x 5 times tan inverse sine 2x. In order to differentiate this, we need to copy the coefficient here, and the differential of tan inverse is 1 upon the function here with power 2 and plus 1 of the formula, and then we need to multiply this entire thing, in fact this 5 as well, with the differential of this function sine 2x, which is 2 cos 2x. Well, this is the simplified form of the differential of f of x. Question number 3. We have 3 different functions: under root, exponential, ln. So under root is always differentiated in this way: 1 upon 2 under root cos 3x, and then we multiply cos 3x with the differential of cos 3x minus 3 sin 3x. We always copy exponential and then we multiply exponential with the differential of its power. And ln can be differentiated in this way: 1 upon tan, and then we need to multiply 1 upon tan 5x with the differential of tan 5x. You can simplify this later. Find the stationary value. This is one of the most important questions. Find the stationary value of A. To get the stationary value of this subject of the equation A, we need to differentiate this A first, and then we need to equate the differential to 0, and then we will get the x coordinate of this stationary point, and then substitute this x into equation 1 to get the stationary value. Stationary value means the value of the subject of the equation. Therefore, A is minus 16. Same concept is here. Find the stationary value of dy upon dx. So in this case, we need the stationary value of dy upon dx. We need to differentiate dy upon dx first, and then we need to equate the differential of dy upon dx to 0, and then we will get x4. Substitute this into 1 to get the stationary value. And this is the answer, minus 16. The stationary value of dy upon dx is minus 16. Now, questions from the book 2. Past papers from November 9 to June 16. I will discuss the solutions of some important questions here. So this is question number 1. A curve has equation. The equation is here, e minus 3x tan x. The question is, find the x coordinates of these stationary points. The curve, give your answer in 3 decimal places. So this is uv. According to uv rule, write you can write anything first because of plus sign. So v is here, and the differential of u is minus 3e minus 3x. Then do vice versa. U is here, and the differential of v is sec square x. Now we have to take e minus 3x common, and then we need to equate the differential to 0, because at a stationary point or points, dy upon dx is always 0, because tangent is always horizontal. E minus 3x, this has no solution, because when you will take ln, it will be invalid. I'll try to always mention this in the solution. And this tan square minus 3 tan x plus 1 is the quadratic equation, and for that we need to use quadratic formula. So here are two answers. Since tan is positive in both the answers, so this is the first answer and this is the second answer, and both answers are in radian. Question number 2 is of implicit functions, because y is not the subject and we cannot make y subject in this equation. So find dy upon dx. This is step number 1 and this is one of the most important steps. Always multiply both sides of the equation by d upon dx. This is very important. Now this is explicit function. It will become 3x square, and this is uv. So according to uv formula, this is u and this is v prime, and this is v and this is u prime. Make sure when you differentiate the implicit function v, always multiply the answer by dy upon dx. This is also the implicit function. So the differential of y cube is 3y square and times dy upon dx, because it is implicit. We always multiply the answer of the implicit function by dy upon dx. Well, we need to take dy upon dx common. So by taking dy upon dx common, we have this gradient. Now part 2. The part 2 is find the equation of the tangent at 2, 1 and give your answer in this form. This is one of the most important part of the question. We need to give answer in this form. Otherwise, we will lose 1 mark. So don't leave your answer here. Give your answer of this form. At 2, 1, dy upon dx is 8 upon 7. So by simplifying this equation, we can get this one. This is the equation of the required tangent. The required equation of the tangent. Well, this is also the implicit function, x ln y 2x plus 1. First, write step number 1, and step number 1 is multiply both sides of the equation by d upon dx. If you will not, if you won't write this step, you will lose 1 mark. Well, since this is uv, so according to uv, this is u and this is v prime. V is implicit, so multiply the differential of implicit by dy upon dx, and this is v and this is u prime. Right side is simple, explicit, so the answer is 2. This is dy upon dx. But see, in answer, we don't have the ln y here. So we need to substitute this ln y in order to prove this answer. So we can substitute ln y from equation number 1. This is equation number 1. By making ln y subject from this equation, we can substitute this ln y. So this is from equation 1. Ln y. Now substitute this ln y here. Therefore, this is the required solution. Well, the second part is simple. We need equation of tangent at y1. We need x coordinate first. We can get the x coordinate by substituting y here. So first get the x coordinate. So when y is 1, then x is minus half. This is the point of tangency. And then the gradient is minus 4, and equation of tangent is y plus 4x plus 1. Parametric equations. So first we need dy upon dx. Since x and y both depend on t, therefore we need to differentiate both with respect to t. So the differential of x with respect to t is 1 upon tan t, and the differential of tan t is sec square t. Well, this is the simplified form of dx upon dt, and this is composite. You can write this as sine t whole square. This will make your differentiation simple. So according to the differentiation of the composite function rule, make this power coefficient, subtract this power by 1, and then differentiate the bracket. So this is the simplified form of the differential of y with respect to t. Always mention the gradient formula and then substitute the values. So the dy upon dt is this, whereas dx upon dt is this. So by simplifying this, we have 2 sine square t cos square t. And the next part is find the equation of the tangent to the curve at the point where x is 0. So first we need y and t. By substituting 0 here, we can get t, and by substituting t here, we can get y. At x0, t is pi by 4. Make sure you do the entire calculus in radian mode. So t is pi by 4, and by substituting pi by 4 into equation of y, we will get y half. So the point is 0 comma half, and the gradient is half. So we can get the equation of the tangent. So the equation of tangent will be this. In this question, it was not mentioned to give the answer in this form. So when it's not mentioned, then you can leave your answer in this form. But when they mention this, then always give your answer in the required form. So read the question carefully. Another example of parametric equations. This is the composite trigonometric. This is the best way to write the composite trigonometric, and this is the best way to write the composite trigonometric, because you can now differentiate this sine power 2 easily. So according to the differentiation rule of the composite function, we can write 2, we can bring this 2 here, so it will become 6, and then sine t has power 1, and the differential of sine is cos. So this 3 will multiply with this 2, it will become 6 power 2, and the differential of cos is negative sine t. So the final answer is minus cos t. Another question of parametric equation. I'm leaving this question because we already have done 2 questions. This one is simple. This question is important. The second part is important. First part is simple. Find the x coordinates of the stationary points of the curve in the interval. So for stationary points, gradient should be 0. So dy upon dx is 0 at stationary points. We all know this. So the differential of sine is cos, and this is the composite. So this will become 12 cos power 2, and the differential of cos is negative sine. If you are good at trigonometry, you can easily handle this equation. Well, sine is positive, so it must be in first quadrant and second quadrant. So there are 2 answers. Now the second part is important. Determine the nature of the stationary point in this interval for which x is least. Now this is very important. We need to check the stationary point at pi by 12, not at 5 pi by 12, because they said where x is least. So this is the least value of x. So we need to check the second derivative at x pi by 12. So this is the second derivative. This is the difficult way to handle this. It would be better if you remove cos square x by 1 minus sine square x. This will make your differentiation simple. Although this method is fine, but if you will replace cos power 2x by 1 minus sine square x, this question will be very simple. Because here you are using uv. When you will replace this cos by 1 minus sine square, you won't need to use uv. Anyway, so the rule is always simplify the function before the differentiation. Here is the simplified form of the second derivative. At pi by 12, the answer is negative. Therefore, the point is maximum. Again, the next question is the same question, is parametric. I'm leaving this. Now this question is important. Implicit function, and this we need the x coordinate of m. So at m, x is positive. This is important. So the step number 1 is this. Multiply both sides of the equation by d upon dx, and then make sure you differentiate the things carefully. This is UV with implicit, this is implicit, this is simple explicit. So differentiate this carefully. You can write bracket here to understand the differentiation of this UV. So for maximum point, we need to equate gradient to 0. Therefore, y square is 6ax minus 3x square, and equation of the curve, let's suppose, is equation 2. We need to solve these two equations simultaneously for the x coordinate of the turning point. So by substituting this y square here and here, we can get the x coordinate. So x cube 6a square x, in fact, minus 3ax square. Let me correct this. This is xy square. So this will become 6ax square minus 3 x cube, plus when you will multiply a, 6a square x, 3ax square and copy this 3ax square. So 3ax square, this will be cancelled out with this 6ax square. Now we have minus 2x cube and 6a square x. Let me simplify this here. So by taking minus 2x common, we have x square minus 3a square. Since x is not 0, so ignore this value of x, and from this thing, from this expression, we have x plus under root 3a, because x is positive at m. So this is the way to simplify, to solve these two equations. This is one of the most important questions because it involves a lot of trigonometry. Parametric equations, and we have to show tan. Make sure you remember the formula of tan, the sum of angle of tan. Tan A minus tan B, 1 plus tan A tan B is equal to tan A minus B. So if you remember this formula, you can easily prove this. Well, first differentiate x with respect to t, and remember this is uv. So differentiate this carefully. And then differentiate y. Well, this is the simplified form of the differential of x with respect to t. Now, this is also uv. So differentiate this carefully and get the simplified form of y with respect to t. Since you know how to differentiate e and cos, therefore I'm not discussing the differentials. I'm interested in the later part, the important part. This is the gradient formula. So by cancelling e minus t, we have this thing. Now remember, this is very important since we have to prove tan. So we need to bring tan here. So by dividing all by cos, all expressions, all terms by cos, we can get the tan function here. So n equal should be here, not here. Well, this is tan t minus 1, this is tan t plus 1. You know, we have to prove t minus pi by 4. So if you expand this, you know, you will get this tan t minus, in fact, you will get this. So to get this solution, this pi by 4, you need to replace this 1 by tan pi by 4, because 1 is tan pi by 4. So if you will replace this 1 by tan pi by 4, you can easily get this solution. And in denominator, you need to write tan t plus 1 as like this, tan t times 1. and 1 is 10 pi by 4. So after writing this whole thing, you can factorize this in this way. So make sure you must be good at with the formula of trigonometry, especially the sum of angle formula, which is used here. So if you are good at trigonometry, you can easily handle these things. This is the implicit function. The question is simple. I'm leaving this. This question is very important because calculations, a lot of calculation is required. So at m, we know x is positive. Find the coordinates of m, and y is also positive. Well, the step number 1 is write d upon dx on both the sides, but listen to me carefully. Don't differentiate this right now. You need to first expand this. First get the simplified form of the function and then differentiate the function. You can differentiate this function at this step, but always try to simplify the function before the differentiation and then differentiate the function. So this is the simplified form of the function. Now you can differentiate this. This is the step number 1. Always multiply both sides of the equation by d upon dx. Now this is uv with implicit. This is this is implicit. This is also implicit. So make sure you multiply the differential of implicit with dy upon dx. Well, x power 4 will become 4x cube. You can write this to outside the bracket to make the differentiation of product rule simple. So this is u, whereas this is v prime. This is u prime. And this is also implicit, so make sure you multiply 4y cube with dy upon dx. This is also implicit, so multiply minus 2y square by dy upon dx. Therefore, we have, we need to, we could equate dy upon dx 0 here. I mean, there is no need to simplify this equation. This step, this step, this step, this step is not important. I mean, you can directly substitute dy upon dx 0 here, here, and here to make the calculation simple. So whenever it's required the coordinate of turning point, then always equate your gradient to 0 over here to make the calculation simple, provided the expression of gradient is not required. If the expression of gradient is required, then you need to get this form. Since in this question, this expression was not required, therefore, we could equate gradient to 0 here. Anyway, you can solve in any by using, you can use any method. This student used this method. She simplified everything and then she substituted gradient to 0 here, and then she got y square 1 minus x square. If you would equate dy upon dx 0 here at this step, you could easily get this thing. So you have choice. I would prefer this method. This method, equate gradient to 0 straight away, if the expression of gradient is not required. I hope you have understood my point. Anyway, this is equation number 2, and this is the equation number 1. This one, you can say this one or this one, both means the same thing. Now you need to solve these two equations simultaneously for the coordinates of m. So by solving 1 and 2, we can get the m. I'm leaving this for you. Parametric again. Now this is one of the most important questions regarding the parametric equations. So in this question, we have composite function here and here. And the most important part of this question is we need the equation of tangent, and t is not given. When t is not given, then this x will be regarded as x1 and this y will be regarded as y1 for the equation of the tangent. Let's discuss the solution of this question. Number 1, we need dy upon dx. Since both functions are composite, therefore differentiate these functions carefully. You can write this as cos t power 4. This will make your differentiation simple. And you can write this sine t whole power 4. So 4a cos cube t, and the differential of cos cube t is minus sine t. This will become 4a sine cube t, and the differential of sine t will be cos t. Get the simplified forms of both, then use first write the formula and then substitute this and get this thing. But remember, don't use this gradient for the equation of tangent. Always use this form of the gradient, because this form will make the calculation very difficult. So for the equation of tangent, let me solve the equation of tangent part here. So it was y minus y1 dy upon dx x minus x1. So y minus y1 is a sine power 40. And gradient is minus sine square t upon cos square t. X minus x1, and x1 I think it was a cos power 40. Now you just need to do cross multiplication. You need to bring cos square t here, you need to multiply sine square here, and then you just need to simplify this and you will get the answer. I'm leaving this for you. You can simplify this. And the last part of this question is show that if the tangent meets the x-axis at P and y-axis at Q, then this distance must be equal to A. Must be A. Well, if this tangent will meet the x-axis at P, then the coordinates of P must be x comma 0, and the coordinates of Q must be 0 comma y. So when you will put y0 here, you will get x coordinate. Similarly, you can get the y coordinate of Q. So, well, this is the equation of tangent. So for P, substitute y0 here. So this is the coordinates of P and this is the coordinates of Q. Well, OP is a cos square t. You can get the distance OP by using distance formula. Let me tell you how to get OP. This is basically magnitude. A cos power 2t, this t is here, whole square. So when you will simplify this, you will get a cos square t. This is the way to get this OP. Similarly, you can get OQ, and by adding these two distances and by using the identity here, you can get this A. Now this is one of the most important questions. First we need expression of gradient in this form, and the part 2 and part 3 are very important. Well, this is UV, so make sure you differentiate the functions carefully. So this is U and this is V prime, this is V and this is U prime. Since we need our answer in the form of tan, therefore we need to substitute sec square by 1 plus tan square x. Sec square is 1 plus tan square x. This is the identity of sec square x. So by factorizing this bracket, we can get this thing shown. Well, the second part, explain why the gradient of the curve is never negative. Well, part 2. Let me solve the part 2 here. As this gradient the answer of part 1 is 1 minus tan x over e power x minus x, in fact, whole power 2. This can be written in this way. So because of this power 2, this gradient will always be positive. So this is the explanation of the second part for this domain. And in domain, you need to mention this positive for this domain. Because when tan is 0, this will become 1 upon e power 0, and 1 upon e power 0 is 1, 1 power 2 is 1. Part 3. The most important thing in this gradient is this power 2. Because of this power 2 and because of this domain, this gradient will always be positive. Meaning the answer will either greater than 0 or equal to 0. It can never be negative. The answer could be 0. Because when you will put pi by 4 here, the answer will be 0. But answer can never be negative. Hence, gradient can never be negative. Part 3. Find the value of x for which the gradient is least. See, if you will observe part 2, the answer of part 2, the least value of the gradient is 0. So you need to substitute 0 here. So when you will put 0 here, you will get x pi by 4. Or you can directly write your answer, because we get 0 in part 2 when we substitute pi by 4 here. You can do this part 3 directly, or you can just do calculation. If you are doing calculation, then must mention this thing. Thus, this exponential will be negative. I mean, invalid. And this is the right answer. Well, this is again one of the most important question, the differentiation of composite ln function. Make sure you won't use power law of ln here, because so sorry, let me get this page. It was page number 30, question number 37. Yeah. So this is one of the most important thing, that ln x whole square is the composite function, and we can never write this as 2 ln x. We can write ln x square as 2 ln x, because this square is on the function, but this square is on both ln and its function. When the square is whole, then never use power law. When the square is on the function only, then you can use power law. So this is the composite function, and the differentiation of the composite function is very important. First make this 2 coefficient, then write this 1, and then differentiate ln x. So let me do this here in detail. So ln x whole power 2, this will become 2 ln x 1, and the differential of ln x is 1 upon x. This is the way to differentiate the composite ln functions. So this is u upon v, whereas this function is composite. So this is v prime, this is v, and this is u prime, and put minus sign of the formula, and then this is v prime and this is u, and this equal should be here with dy upon dx. Well, this is the simplified form of the gradient. Now equate gradient to 0 because of turning point, and please never cancel this ln. I'm sorry. Yeah, always factorize your equation. I mean, Don't write this equation like this. Let me check, is this ln x whole square? Yeah, this is ln x whole square. This is the correction. This is ln x whole square. Yeah, I was saying don't write like this, and don't cancel this ln with this ln, because we always factorize the equation. We never do cancellation in this way. So bring everything on left side, take ln x common. So this is 1, and from this equation we have x e square. For y coordinates, substitute both the values of x into equation 1, and these are the coordinates of the turning point. This is all. Differentiation is over. I hope you will watch all my lectures on differentiation before watching this lecture. And in order to be good at differentiation, you need to practice a lot. First, understand the concepts, and then practice a lot. Avoid backbiting, and good luck. I hope these lectures will help you all. Allah Hafiz.